Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Welcome to this deep dive into Apache SeaTunnel, an open-source, high-performance data integration tool. Whether you're synchronizing databases, streaming logs, or building ETL pipelines, SeaTunnel provides a flexible and scalable solution. It's designed to work seamlessly with modern big data engines like Spark and Flink, making it a powerful choice for intermediate to advanced developers. So why choose SeaTunnel over other tools? Unlike many legacy systems, SeaTunnel supports both batch and streaming workloads in a single framework. It integrates with multiple execution engines, giving you flexibility. Its plugin-based architecture allows you to extend functionality easily, making it future-proof for evolving data ecosystems. At its core, SeaTunnel follows a master worker architecture. The master node handles job parsing and scheduling, while worker nodes execute the actual data processing. Jobs are defined using YAML or JSON, making them portable and easy to version control. Plugins are modular, allowing you to mix and match sources, transformations, and syncs as needed. Jobs in SeaTunnel are defined using YAML or JSON. This allows for clear, human-readable configuration files that can be reused across environments. You can define sources like Kafka or MySQL, apply transformations like filtering or enrichment, and output to syncs like HDFS or Elasticsearch, all in one declarative file. One of SeaTunnel's strengths is its engine agnosticism. You can run jobs on Apache Spark for batch processing, Apache Flink for streaming, or even in standalone mode for lightweight tasks. This flexibility allows you to choose the best engine for your specific use case without rewriting your pipeline logic. The plugin system is what makes SeaTunnel truly extensible. You can plug in various data sources like Kafka or MySQL, apply transformations like filtering or joining datasets, and push results to syncs like Elasticsearch or Hive. All of this is handled through a consistent API, reducing the learning curve for new integrations. Source plugins are responsible for ingesting data into the pipeline. SeaTunnel supports a wide variety of sources including Kafka for streaming, MySQL for relational data, and HDFS for file-based ingestion. Each source can be configured for offset management and schema inference, ensuring data consistency and reliability. Transform plugins allow you to process data mid-pipeline. You can filter rows, join datasets, or perform aggregations. SeaTunnel also supports user-defined functions, UDFs, for custom logic. The system handles schema evolution gracefully, adapting to changes in data structure without breaking the pipeline. Sync plugins are where transformed data is written. SeaTunnel supports popular syncs like Elasticsearch for search analytics, Hive for data warehousing, and Kafka for streaming outputs. Writes can be batched or streamed, and retry policies can be configured to handle transient failures gracefully. To get the most out of SeaTunnel, you need to tune performance. This includes adjusting parallelism levels, optimizing memory and CPU allocation, and choosing efficient serialization formats like Parquet or Avro. These tweaks can significantly reduce job runtime and resource consumption. Monitoring is crucial for production pipelines. SeaTunnel provides built-in logging and metrics that can be exported to tools like Prometheus and visualized in Grafana. You can track job status, monitor throughput, and debug errors with detailed logs. SeaTunnel can be deployed in multiple environments. You can run it on a standalone cluster, on Yarn for Hadoop environments, or in Kubernetes for cloud-native deployments. Each deployment model offers different benefits in terms of scalability and resource management. Security is built into SeaTunnel. It supports authentication and authorization mechanisms, ensures data is encrypted in transit, and allows role-based access control for managing user permissions. These features are essential when dealing with sensitive enterprise data. How does SeaTunnel compare to other tools? Compared to Spark, it's simpler for ETL use cases. Compared to Flink, it offers a richer plugin ecosystem. And unlike Airflow, which is more orchestration-focused, SeaTunnel is built for real-time data integration. Let's look at a real-world example. In e-commerce, SeaTunnel can synchronize real-time inventory data from multiple sources, aggregate sales metrics, and push them into a data warehouse like Snowflake for reporting. This ensures accurate, up-to-date analytics for business decisions. In IoT applications, SeaTunnel excels at ingesting telemetry data from thousands of devices. It can process this data in real time to detect anomalies and feed insights into analytics platforms like Elasticsearch or Grafana. This enables proactive system maintenance and optimization. Performance benchmarks show that SeaTunnel can handle high-throughput workloads with low latency. It scales efficiently to thousands of nodes and uses resources more effectively than legacy ETL tools. These benchmarks make it a strong candidate for enterprise-grade pipelines. SeaTunnel benefits from an active open-source community that contributes plugins, documentation, and improvements. The ecosystem is growing rapidly, with regular updates and a transparent roadmap. This ensures the tool evolves with the needs of modern data engineers. Ready to get started? Download SeaTunnel from the official site, install it locally, and write your first job using the YAML syntax. You can run it in local mode for testing or deploy it to a cluster for production use. The documentation and community are great resources for learning. To ensure success with SeaTunnel, follow best practices like validating schemas to avoid runtime errors, optimizing resource allocation to prevent bottlenecks, and monitoring job performance to catch issues early. These practices lead to more robust and maintainable pipelines. For advanced users, SeaTunnel offers features like custom UDFs, dynamic job scheduling, and multi-tenant setups. These capabilities allow you to tailor pipelines to complex enterprise requirements and integrate with existing infrastructure seamlessly. Even with best practices, issues can arise. Common problems include job failures due to misconfigurations, performance bottlenecks from resource limits, and schema mismatches during data ingestion. Understanding how to troubleshoot these issues is key to maintaining reliable pipelines. Looking ahead, the SeaTunnel roadmap includes exciting features like a web-based UI for managing jobs, deeper cloud-native integration, and AI-powered pipeline optimization. These enhancements will make SeaTunnel even more powerful and user-friendly. Apache SeaTunnel is a powerful and flexible tool for modern data integration. Whether you're building real-time ETL pipelines, syncing databases, or processing IoT data, SeaTunnel offers the performance, scalability, and extensibility you need. With a growing ecosystem and active community, it's a tool worth mastering. If you found this tutorial helpful, please give it a like and subscribe for more deep dive content on data engineering tools. Leave a comment with your questions or topics you'd like to see next. We love hearing from our community. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.